Welcome to the lecture on step response of RL and RC circuits. So, coming to the learning objective of this today's lecture is to determine the step response of RL circuit, and the second learning objective of this lecture is to determine the step response of RC circuit and also to solve some example problems on this step response of RL and RC circuits. So let us see one by one. So coming to the first one is step response of RL DC RL circuit. Okay. Now see. So step response means here. So when we apply the step input, the response we are calling as a step response. So here the switch is closed at t equal to 0. Okay, the switch is closed at t equal to 0. Then what is the response? What is the step response of the circuit? So after switch is closed, so we apply the KVL in this loop. Therefore, you will get Vs equal to the voltage drop in the resistor. So V is voltage across the resistor are equal to I into R, that is R into I of t, plus the voltage across the inductor L is equal to L into di by dt. So this is the equation number 1. Now if you arrange the equation, that means now see here you bring this L to the LHS side. So the equation will become like this. So di by dt equal to minus R by t, that is R into I of t plus Vs by L. That means, so what we will do? So we will bring this R into I of t to the L into di by dt to the LHS side, and Vs is to the RHS side. Therefore, you will get this equation. So di by dt equal to minus R into I of t plus Vs by L. So that equal to, now take this minus R by L as a common. So I of t minus Vs by R. So this is the equation number 2. Now we want to find out the step response, means we want to find out the current, that is response in the sense current we are finding in the circuit. So to find out this current, you keep the di is in the left LHS side only. Now bring this dt to the RHS side. Therefore you will get, so di equal to minus R by L into I minus P by R into dt. Okay. So now minus R by L into dt is equal to the di by I of t minus Vs by R. So this is equation number 4. Now to cancel this differentiation, we have to integrate on both sides. Then only it is easy to find out the current. So there is a RHS side, there is a di is there in equation 4. So to find out the I, so we have to integrate on both sides. So therefore integration and differentiation will get cancelled. Therefore it is easy to find out the current I. Now apply the integration on both sides from t equal to 0 to t. So integration limits. Now therefore, so thus minus R by L into, so 1 dt is nothing but t. So you know that log I of t minus Vs by R. So from the differential, that integration formulas, I naught minus 1 Vs by R. So this is the equation number 5. Now hence, what about the current? So therefore the current I of t we want. So you send this, if you remove the log on both sides, that is ln on both sides. So that means, if you want to remove this ln, so you will get the exponential, that is e to the power of minus R by L into t. So once this e to the power of minus R by L into t, then you will get that I of t minus Vs by R by I naught minus Vs by R equal to e to the power of minus R by L into t. Now keep this I of t minus Vs by R in the RHS side, and you bring this I naught minus Vs by R to the LHS side. Therefore you will get I of t equal to Vs by R plus I naught minus Vs by R into the power of minus R by L into t. So this is the step response of the RL circuit. Okay. So the voltage. So once you find the current in any inductor resistor, then it is easy to find out the current in this circuit. So that is I of t, the voltage across the resistor is equal to I into R, and voltage across the inductor is L into di by dt. Therefore, V of t equal to, so Vs minus I naught into R into the power of minus R by L into t. That means this is the voltage across the okay, voltage across the inductor. So this V of t we have to find and I of t we have to find. So this is the response. So in the circuit given that, so I have the red color one, I have I, that is the step response of the RL circuit, and the voltage we have to find. So therefore we found that the current is I of t equal to Vs by R plus I naught minus Vs by R into e to the power of minus R by N into t. So this is small mathematical operations involved here. Of course we can solve this mathematical equation. So small integration you have to do that. Okay. So therefore the voltage across the inductor V of t is equal to, so Vs minus I naught into R into the power of minus R by into t. So this is the response, that is the voltage and current in the inductor. Now let us solve one problem on this concept. So the problem is, the switch is closed at t equal to 0 and the switch opens. Okay, find the expression for IL of t and VL of t. Okay, that means the switch was closed, but at t equal to 0 the switch is open. So what is the current and voltage in the inductor? So this is the question. Now first step 1, you have to find out the tau, that is a time t greater than equal to 0 the switch was open. Okay, earlier that is a t equal to 0 minus the switch was closed, at t equal to 0 plus, that means t greater than 0 the switch was opened. Now when the switch was opened, now we have to draw the equivalent circuit to find out the time constant, that is tau of the circuit. So to find out the time constant tau of the circuit, we have to kill the active sources. So that is voltage source is replaced by short circuit. So we have to find out this Thevenin's resistance. In the same manner we have to find out the resistance. Here RT is equal to, as these 2 ohms and 3 ohm resistors are connected in series, therefore 2 plus 3 is equal to 5 ohms. And we know for the RL circuit the time constant tau is equal to L by R. Therefore L is given as 1 by 4 Henry. So therefore 1 by 4 into 5. So equivalent resistance we got here 5, therefore 1 by 20 seconds. That means the time constant of this given circuit is 1 by 20 seconds. Okay, once you find the time constant of the circuit, so at t equal to 0 minus, that is initial condition before closing the switch. Okay, the switch was closed. That is before you open the switch, already the switch was in closed position. Now in this case we have to draw the equivalent circuit of with 3 ohm shorted and the inductor behaves like a short circuit. Now see here. So this is what the condition. Switch was closed means, so this is the equivalent circuit. How? Because this is the actual original circuit, this one. Now switch was closed means what? When the switch is closed, so the 3 ohm resistor is in parallel with the 0 ohm. So 0 and 3 ohms are in parallel, therefore the equivalent resistance will become 0. That is 0 into 3 by 0 plus 3 is 0. Therefore 2 ohm in series with the 0 ohm, and of course the switch was closed, the inductor for a long time, so the inductor acts as a short circuit. Therefore this is the equivalent circuit when the switch was closed. So this is the equivalent circuit when the switch was closed. Now we want to find out the current in this circuit, that is called IL of 0 minus. Means before opening the switch means a switch was closed. So what is the current in the circuit? That current we are calling as a IL of 0 minus. Now it is easy to find out the IL of 0 minus. That is only the voltage source is there and resistor is there. So current flowing through the resistor I is equal to voltage by resistance, that is V by R from the Ohm's law. Therefore it is easy to find IL of 0 minus is 10 by 2, that is 5 amperes. 5 by amperes. Okay. Now what is step 3? So at t equal to 0 plus, that means after the switch was open, the instant switch was open, the current in the inductor is continuous. Of course we know that the property of inductor, so inductor does not allow the sudden changes in the current. Therefore the moment you open the switch, so what was the current flowing earlier, that is 2 amperes, so same current flowing in the inductor. Okay, therefore IL that is I naught is equal to IL of 0 plus is equal to IL of 0 minus. What is this I naught mean? Initial current. I naught mean initial current. So the IL of 0 plus means the moment you open the switch, so what is the current means? That current must be equal to the current when the switch was closed. So that is equal to 5 amperes. Now the next step is, so at t equal to infinity, that means that the time passes, as the time is increases, that is after a long time the switch has been left open. Okay, after the switch is open. Now what will happen? The inductor will once again behave like a short circuit. Same circuit. So inductor behaves like a short circuit. So this is the condition. Because open circuit na, switch is open circuit, but 3 ohm resistor will get added in the circuit now. Okay, but inductor as a short circuit. That is called here IL of infinitive, means after long time when the switch was open, of course in the steady state inductor acts as a short circuit. Therefore, then what is the current here? So IL of infinity, that is IL of infinity equal to total voltage P by R. Again from the Ohm's law. So total voltage is 10 volts by R is nothing but your. So our 2 ohms and 3 ohms are in series. Therefore 2 plus 3 is 5. So 10 by 5 is 2 amperes. So that means the initial current, so IL of 0 minus is 5 amperes and the final current is 2 amperes. Final current is 2 amperes. So this is what the result. So therefore IL of t is equal to Vs by R. So see here, this what is this Vs by R indicates? See, this Vs by R indicates this IL of infinity, that is steady state current, that is 2 amperes. Now I naught minus Vs by R into the power of minus R by L to t. So this is the transient current. So steady state current and transient current. So the total current in the circuit is the sum of steady state current and transient current. Of course, this transient current will vanish after some time constants. Okay, after some time constants. So it will depend upon the ratio of inductance and resistance. If the inductance of the circuit is high, so it will take much time to complete that, and if the resistance is high, so it will take less time. So it depends upon the time constant, that is tau is equal to L by R ratio. Okay, so therefore IL of t is equal to 2 plus, now we substitute that I naught value and Vs by R and e to the power of minus R by L to t. Once we already got that values, I naught is 5 amperes, so Vs by R also we got just now 2 amperes, so R is given, L is given. So you will get 3 into e to the power of minus 20t amperes. This is the final current in the given circuit. IL of t equal to, so steady state current is 2 ampere plus transient current is 3 into e to the power of minus 20t amperes. See, this e to the power of minus 20t is explaining that the current is decaying. The current is decaying. That means transient current will no longer exist. Transient current will no longer exist. As the time passes to infinitive, see, now put your t equal to infinitive. So e to the power of minus 20 into infinitive, e to the power of minus infinitive. So e to the power of infinity minus infinity is 1 by e to the power of infinity. 1 by e to the power of infinity is 1 by e to the power of 0. 1 by 0. 1 by 0, sorry, 1 by e to the power of infinity 1 by 0. Okay, so what you will get? That is called 0. 1 by e to the power of infinity. 1 by infinity means what? 0. Anything to the power of infinity is 0. Therefore 1 by e to the power of infinity is 1 by infinity, that is 0. Therefore, as the time passes, this transient current will decreases to the 0. Okay, only the steady state current will exist in the circuit, that is 2 amperes. That is called our steady state current. Now, and the voltage. So once you find the current, it is easy to find out the voltage. So VL of t is equal to, so this simply differentiate this L into di by dt, then you will get this equation. Okay. So Vs minus I naught into R, it is e to the power of minus R by L to t. As same as like earlier we derived the voltage across the inductor in the RL circuit, step response. Okay, so therefore VL of t is equal to minus 15 into e to the power of minus 20t volts. Now let us see the step response of RC circuit. Okay, step response of RC, that is the resistance and the capacitance series. Now see. RC circuit, see, the switch is closed at t equal to 0. So earlier the switch was open, but at t equal to 0 the switch is closed. So what is the current, that is I, red color one, I, and voltage across the capacitor Vc of t. You have to find out that values. Okay, so from the circuit you apply the nodal analysis at this switch junction. Okay, so the algebraic sum of the currents leaving the junction is equal to 0. Or entering currents equal to leaving currents into the junction. So current entering currents is Is. So one current Is is entering. Next to that current is leaving. Let us say R. So Is is equal to current leaving is through the capacitor, that is C into dV by dt. So dVc by dt plus Vc by R. Of course the resistor and capacitor in parallel. Therefore the voltage is same across these two elements. Therefore, so if the voltage across the capacitor is Vc of t, then the voltage across the resistor also Vc of t. Therefore, you will get this equation Is is equal to C into dV by dt plus Vc by R. Now this is equation 1. Now see, so small unit is your mathematical operations. So you bring this C to the LHS side and you do some mathematical operations to get the response. See, I see Is of C, Is by C equal to dVc by dt plus Vc by Rc. From this what we can find? So we want to find out here Vc, the voltage across the capacitor. Okay. So you know from the nodal analysis we can find out the node voltages in the same manner. So some mathematical techniques with RL the voltages. So you do some integration differentiation. So that is to cancel this differentiation you do the integration and you will get this equation. So Vc of t equal to Is into R plus V0 minus Is into R into e to the power of minus t by Rc. So where Rc is a time constant tau. Okay, minus t by tau. So tau is equal to time constant. So time constant of the RC circuit is a product of resistance and capacitance RC. So and the current is, once you know the voltage you can use to find out the current. You differentiate the voltage equation and multiply with C, then I equal to C into dV by dt, then the current I of t is equal to Is minus V0 by R into e to the power of minus t by tau. So this is the response of the RC circuit, step response of the RC circuit. Now just to take one example problem to understand this concept. So the switch has been in position A for a long time. See here switch is there are two conditions are there, switch at A and switch at B. For a long time switch was at A and at t equal to 0 the switch moves from A to B. So what is the Vc of t? That means find Vc of t for t greater than 0. That means when the switch moved from A to B, we have to find out the voltage across the capacitor and calculate its value at t equal to 1 second and t equal to 4 seconds. That means at t equal to 1 second, what is the value voltage across the capacitor, and at t equal to 4 seconds, what is the voltage across the capacitor. Let us solve this problem. Okay. Now first one is the capacitor behaves like an open circuit. Of course, just now we have seen the inductor problem. So here the capacitor behave like an open circuit. In the steady state condition, capacitor act as an open circuit, inductor as a short circuit. So therefore, and see before closing the switch, see first the switch is at A. So the switch, when the switch is at A, the circuit is continuous for a long time. That is a steady state. In the steady state, capacitor acts as open circuit. Therefore, we are opening the capacitor. Now, how to find out the voltage across this capacitor? So you want to use any technique. See, I can use here voltage division principles as this 24 volts, 3 kilo ohms, 5 kilo ohms are in series. So we can apply the voltage division principles in this circuit. Therefore, the voltage across the 5 kilo ohm resistance is equal to the voltage across the capacitor Vc of 0 minus. Therefore, so Vc of 0 minus is equal to total voltage according to the voltage division principle. Total voltage into that resistance 5 kilo ohm by total resistance 5 plus 3 8. So 24 into 5 by 8. 8 3s are 24. So 3 5 is 15. Okay. So therefore you will get the 15. See here Vc of 0 minus. Voltage division. So total voltage 24 into that resistance 5 kilo ohms by total resistance 5 kilo ohm plus 3 kilo 8 kilo ohm. Therefore, so 8 1 is 8, 8 3 is 24. So 3 5 is 15 volts. That means when before the switch is moved from A to B, the voltage across the capacitor, that is the initial voltage is 15 volts. Okay. So now next step is at t equal to 0 plus the switch is moved from A to B position. Then what is the voltage across the capacitor? Now see, already told you the capacitor does not allow the sudden changes in the voltages. That means instantaneously the capacitor voltage will not change, remains unchanged. Voltage across the capacitor remains the same. As like inductor, as before example problem, so inductor does not allow the sudden changes in the currents. So the current remains same for a while. In the same manner here voltage. Okay. So therefore Vc of 0 plus is equal to the Vc of 0 minus, that is 15 volts. Now we have to find out the steady state, that is once the switch moved from A to B after long time, then what is the response? That is, at time passes, at time t equal to infinity, the capacitor again behave like a open circuit. So since it is being supplied by a constant source, so you make it open circuit. Now see, this is circuit when the switch moved from A to B. So from the circuit A, the first part is disconnected because switch is moved to A to B. So here capacitor acts as open circuit. Now what is the voltage across the capacitor here? DC of infinity is equal to 30 volts because open circuit the current is 0, the voltage across the resistor is 0. So whatever the total voltage is, this 30 volts will get appear across this capacitor. So therefore DC of infinity is equal to 30 volts. Now, so in the step y, so now we have to add this transient and steady state. So initial voltage is 30 volts plus. So we will substitute that in the formula what we have derived. So 15 minus 30 into e to the power of minus 0.5 t. Okay, that is equal to 30 minus 15 into e to the power of minus 0.5 t. That means this 30 volt is the steady state voltage and the 15 into the power of minus 0.5 t is the transient voltage. So I said you this transient will no longer will exist as the time passes that is infinity. Now substitute the t equal infinity. So 15 into e to the power of minus 0.5 into t means, so e to the power of minus 0.5 into infinity. That means 1 by e to the power of 0.5 into infinity. That means 1 by infinity. 1 by infinity means 0. So 15 into 0 is 0. That means as the time passes, time increases, this second term, that is 15 into the power of minus 0.5 will vanish. Therefore, only the steady state voltage is 30 volts. Now, he asked you to find out the voltage at t equal to 1 second and voltage at t equal to 4 seconds. Now, substitute in place of t 1. Therefore, you will get a VC of t is equal to 20.9 volts. That means the moment you open the switch, okay, switch move the switch from A to B position. So 1 second the voltage of the capacitor is 20.9 volts. After 1 second, instantaneously 30 volts only, but after 1 second it is reduced to 20.9 volts. Again after 4 seconds, so 28 volts. So when the time increases, so this voltage will become 0. That's what the class today's lecture. So find out this step response of RL and R circuit and how to solve the circuit problems on this concept. Okay. So thank you everyone for listening to the class. So we'll see in the next class. Thank you.